All right, let's kick things off with a crazy comparison. We're going to pit two materials against each other. One builds our cities, and the other, well, it builds us. We're talking concrete versus bone. And I'm willing to bet you think you know which one is stronger, but you might want to think again.
I mean, really think about it. What if the strongest, most advanced material in your life isn't in your car or your house, but it's you? What if it's literally holding you together right this second? Well, let's dive in and find out. Okay, so let's get to the main event. In one corner, we've got the heavyweight champion of construction, concrete, and in the other corner, the biological marvel that is human bone. This is one showdown you probably didn't see coming. And right out of the gate, we get a total shocker. We're looking at something called compressive strength, which is just a fancy way of saying how much squeezing something can take before it breaks. Now, your standard concrete, it can handle about 40 megapascals. But our cortical bone, that's the super dense outer layer, it clocks in at around 170. Do the math. That's more than 4 times stronger. Incredible, right? But here's where it gets really mind-blowing. It's not just about that raw strength. Bone is doing all this while being way, way lighter. And it can repair itself. I mean, can you imagine a sidewalk healing its own cracks? No way. So, what's the secret? How in the world does nature pull off this engineering magic?
Well, to crack that code, we've got to look at what they're actually made of. It's kind of like looking at the recipe. And you're about to see their core ingredients are from two totally different worlds.
And wow, is it a contrast? Concrete is, well, it's basically just rocks and sand held together with cement. Super simple, kind of brittle. But bone? Bone is on a whole other level. It's a sophisticated, living composite material. Don't think of it as a rock. Think of it more like the high-tech carbon fiber you'd find on a race car.
So here's how that recipe works. First, you start with a flexible framework made of a protein called collagen. This stuff is like the rebar in reinforced concrete. It gives the bone its ability to bend and not snap. It's tensile strength. Then you weave in countless tiny super stiff mineral crystals. That's where the compressive strength comes from. It's this perfect tag team of flexibility and rock-solid hardness.
And you know what's wild? This whole idea of mixing a flexible material with a stiff one, that's exactly what our smartest aerospace engineers do today to make things like carbon fiber for jets and spaceships. But nature beat us to it. As the source material puts it, evolution perfected this design hundreds of millions of years before we even existed. Talk about being ahead of the curve. Okay, so the ingredients are genius, but that's not even the whole story. The real secret isn't just what bone is made of, it's how all those ingredients are organized. It's built in these incredible layers, like a Russian nesting doll of pure strength. So let's zoom in, shall we? On the big, macro level, our long bones are basically hollow tubes. This is a classic engineering trick. It gives you maximum strength for minimum weight. Okay, now let's zoom in closer to the micro level. Here you see these things called osteons, which are basically bundles of fibers arranged like plywood. This is what stops the bone from twisting and breaking. And if we go even deeper, down to the nano level, you see the individual crystals and collagen fibers interlocking. They're literally designed to catch and stop tiny cracks before they can even get started. This whole structure is bone's secret weapon against failure. See, when a tiny crack tries to form in bone, it doesn't just get a free pass to rip right through. No way. It immediately runs into one of these layers, gets forced to change direction, and basically runs out of steam. But concrete, it has zero defense. A crack in concrete is a one-way street to disaster. That's why it can fail so spectacularly all at once. But all of that, as amazing as it is, pales in comparison to bone's ultimate trump card, the one thing that sets it completely apart from any material humans have ever made. And it's this: bone is alive. There's actually a scientific principle for this called Wolff's Law. And what it means is that your skeleton is smart. It's constantly adapting. So if you decide to take up tennis, your bones in your arm literally sense that new stress. And they're like, okay, time to bulk up right here. They rebuild themselves to be stronger exactly where you need it most. Your driveway, on the other hand, it just sits there, getting weaker every single year. And how does it do this? It has its own 24/7 maintenance crew working inside you. You've got these cells called osteoclasts. They're the demolition team. Their job is to go around, find tiny bits of damage or old bone and clear it out, and right behind them comes the construction crew, the osteoblasts, who lay down fresh, strong, new bone. It's this non-stop cycle of tear down and rebuild. And the result of all this tireless work is Honestly, it's just staggering. Over the course of about 7 to 10 years, this process replaces almost your entire skeleton. Think about that. You are walking around in a brand new, fully upgraded skeleton roughly every decade of your life. So let's bring it all home. Let's put these two head to head and look at the whole picture. When we do that, the winner isn't just clear, it's not even a contest. All right, let's look at the final scorecard. Compressive strength? Check, bone takes it. Tensile strength? Resisting being pulled apart? Bone is a champion. Concrete is awful at it. Is it lightweight? Yep, that's bone. Can it repair itself? You bet. Is it adaptable? Absolutely. Concrete gets a big no on all of those. Folks, it's a clean sweep, a total knockout. And that really gets to the heart of it, doesn't it? This whole thing was never really about which one is stronger in a simple, brutish way. The real story, the true genius of bone, is its incredible holistic design. It's strong, it's tough, it's light, and it's alive, constantly adapting and healing. It's a masterpiece. So the next time you find yourself marveling at some incredible piece of engineering, like a massive bridge or a skyscraper, just take a second and think about the brilliant, living architecture that's holding you up. It really makes you wonder, right? What other incredible secrets are just waiting for us to discover in nature's blueprints?